Hello, I am Ahmet Talha Aysan. This video is for data mining lesson projects presentation. Uh, my project is house price prediction model in Python. Introduction: after the California housing price dataset was selected, data exploration and data analysis was performed. Linear regression and random forest methods were developed from data mining models to fit the dataset in my analysis, visualization, and exploratory graphs were created to help me exploit the finding of my analysis. Loading datasets section. I use the Python Jupyter Notebook environment is an ideal environment for our projects, as the project includes data science topics such as data exploration, data preprocessing, and feature engineering. We need basic data science libraries like NumPy, Pandas, Matplotlib, Seaborn, Scikit-learn. California housing price dataset from Kaggle will be used for the project. The data pertains to the house funds in a given California district, and some summary sets about the based on the 1990 census data. We wanted the data aren't cleaned, so there are some preprocessing steps required. The columns are as follows. Their name are pretty explanatory, like this. Longitude, a measure of how far west a house is, a higher value is farther west. Latitude, farther north. Housing median age, median of the houses within block. A lower number is a neighbor building. Total rooms, total bedrooms, population, households, total number of households. A group of people residing within a home unit for a block. Median income, median house value, ocean proximity, the value of the house. So this value will be a regression test. An attempt was made to estimate the value of the house based on all values to find download from the that is called housing.csv. That's our libraries are added and the dataset is loaded. Data exploration section. First, data.drop and empty values are cleared from the data frame. We have a total of 20,413. The data is split into train and test data, and they are split into X and data. This is very important because what you want to do here is to train and evaluate them all on a single dataset. It's except median house value and median house value. This is median house value. Median house value. What we do is that it is the data frame without the target variables. So there will be data dropouts and the target variable, which is the median left. It has been observed that the x is equal to 1 since we dropped the house value and one column, and here was just the median house on the contrary. X-train, X-test is classic, E-train, E-test, train split. Test size is 0 watts, true. Train data like this in figure 5. Some basic operation have been made with the train data here. Exploration of numerical features does not involve ocean proximity. For example, a histogram is obtained for train data point his distributions like this. Hard function that generates a coloration heat map. Before drawing it is show what it looks like. The data core is trained. This gave us a coloration matrix. Core function in figure 7. It seems in the heat map that each feature has correlation with itself, so every attribute is the same value time, and then outer correlation for feature combination are seen in figure 88. By looking at the actual correlation number, one can say that the color map would be yellow, green, blue. According to the table, the correlation with the median home value show that the median income of a block is highly correlated. The median value appears to be high or quite strong. So this is a pretty important variable to look at. It makes a great estimator of the home's value. For example, it seems that latitude is negatively correlated. The house is part of these coordinates with its value. Data preprocessing session. It will be now go into preprocessing, and as you can see that a lot of croquet features here. Total rooms are on the property. Households with total bedrooms and population highly skewed appear to be skewed to the right in statistics, but appear to be skewed to the left visually. The data is skewed. This is not nice Gaussian in figure 10. It's the Bell curve. So what is done for the properties is to take the logarithm of these properties. Logarithm of these properties in here. Figure 9. We use a NumPy library log function, total rooms, total bedrooms, population, households. The values for total rooms, total bedrooms, population, and how to increase it by 1 to avoid 0 values. Differences like in here and here. Longitudes, total rooms, total bedrooms, population, and households. When the codes here is run, their values are seen. Now it seems that we have something more like a Gaussian belt. Continue. The graph in the figure show figure 20 and 13 show how proximity and the location of individual blocks affect pricing. It's arranged so that the x coordinate is latitude and the y coordinate is longitude. Then the data itself is the trained data, and the color will be set to our target variables, which is median house volume. The palettes will be called N1. So what is seen here is median house value. So the more red, the more expensive the house, and the more blue, the less expensive. Here. In feature engineering section, we have a number of features that are interesting on their own, but can combine them with the more interesting features. For example, here we have total rooms per block, and we also have total rooms. The interesting thing is the number of the bedrooms per room. So how many rooms of those rooms are bedrooms? So this can be a separate feature. It can also be said that the proportion of bedrooms, the ratio of bedrooms found by dividing the total bedrooms with the trained data by sum of the trained data. Another feature can be added as well. For example, total rooms, but if there is block with more households, there will like more rooms for the households. Therefore, the rooms by themselves do not give us the full picture. What we want to do is also to have trained data. Is it desired to know how many rooms there are per household. Linear regression model. What I want to do in this project to train multiple models, what we want to do in this section is to create a simple model that can be trained. Linear regression was used for the model. The training data is divided into X-train and Y-train. The data here is split into the original data. The target variable is dropped again here. So the median house value X is 1, and the Y value is where the Y feature is located. Then the model was fit, and next step is scale the data in here. And no hyperparameter adjustment was required for linear regression. We will see run regression, target prediction, and how that perform for the other model. Basically, everything that is done with trained data has been done. The next step is modify trained data to test data. So the data is tested. There are 16 columns in the train and test data. When we apply the test and test range.score function, the result is 0.668, which isn't too bad, but isn't too good either. Random forest model. In this section, the room forest algorithm will be counted. It has been observed whether this model is a strong model. Hyperparameter setting was made and tried to find the most suitable model. The figure 19, we import the random forest regressor class from the scikit-learn.ensemble model. This class allow us to do regression with random forest algorithm. We created an object named forest, which is an example of the random forest regression class. This object represents our random forest regression model. We call the fit method on the forest object we create. This is used to train the random forest regression model. It's train same. When we apply the X-test and Y-test score function, the result 0.811, which is much better than in regression. Hyperparameter in here. An estimator determines the number of trees. Mean sample split determines the minimum number of the sample in node splits, and max depth determines the maximum depth of the tree. Best forest score is 0.809, which is much better than linear regression. Conclusion: as a result of the project's housing price datasets was obtained from Kaggle to perform exploratory analysis using the necessary preprocessing and engineering techniques. The dataset was scaled and then evaluated by creating different models. First classification was made using the logical regression. In addition, an experiments was carried out with a simple decision tree. In this process, designing different features has been tried and some features have been removed when necessary. In this experiments, it was predicted that I could improve the performance of each method. This project can be considered as an example of the real data science and machine learning projects or analysis. And these studies will make me a better data scientist and have definitely allowed me to learn new things. Experiences has been gained in this process, and skill in data science have been developed. Thank you. This is my project report and presentation. Thank you.